For this week's homework, our first problem, we had to create an account using the class structure and then instantiate that and do a withdraw, deposit, and print out the balance, monthly interest, and date created. So to do that, we had a class account. We had some private variables, the account ID, balance, interest rate, which was set to 4.5% across the board, and our date created. Now, it asks us to create a default constructor, which is the account, has no parameters. Then we had a regular constructor, which is the account with the ID and the balance. Then we had a function to return the ID number, to return the balance, to return the monthly interest rate. It was already input as a decimal, so all I had to do was divide by 12. And we also were able to get the monthly interest, the date created, a withdrawal function, and deposit. Also, I had an output in here for some testing. So we created an account for my brother Jared as the account ID that was provided and the money, withdrawal, deposit, and then we print out balance, Jared, with the getVal function, and then our monthly interest, and we use that function within the class, and the date created. For breakpoint 10, we had to use the quadratic formula, and we had a class. We included the A, B, and C. We had functions to access and get A as well as B and C. Then we had a function to get the discriminant, which is b squared minus 4ac. And then depending on what the answer to that was, we would get our root or our other root or both. So the user inputs values for A, B, and C. We console input those in. And then here is instantiating a object formula. And then if the discriminant is greater than 0, we know there are two roots. So we get root 1, which is either positive or negative, and then root 2. If it is equal to 0, we know there's only one root, and we get that. And if it is negative, then there is no roots. The third one was probably the most tricky. Unfortunately, I had done a program like this in the past. I was able to use this struct function basically, which makes working with ordered pairs much easier. So pair, double, double is where PDD comes from, and that will equate and allow us to set ordered pairs to a variable. So for our main, I just have a bunch of variables here to make sure there was no cross-contamination. So enter the endpoint of the first line, second endpoint, and within what I'm doing with the struct is use the makePair function, and the two user inputs go into a variable that's just labeled A. So our first endpoint is A, second is B, the second line is C and D. All right, so we're saying the intersection is equal to the function up here, which is line intersection, which has all of our 4 endpoints. And then it just goes into the math. So second endpoint minus the first. The 2 seconds subtracted and the 2 first subtracted, and those go into variables, and so on and so forth. And if the determinant is 0, then we know that they never cross. So that means the lines are parallel. And I have a flag that will change, so that way we know not to do any of the rest of this function. Otherwise, it will determine the pair and will return that pair. If the flag is still 0, then it will print out the intersection because we know that there is one, and we'll go to the function of display point, and it just displays the 2 points. All right, for the final problem this week, we had to basically use the gladiator method, but within a class rather than a simple array, also a 2-dimensional array as well. So we input the row and column sizes from user input. Then we had to declare our dynamic array, which is 2-dimensional. So our 2-dimensional array with the row, and then we add on to the columns to that. Then we can print out enter, and then I did this for a column to know how many values the person needed to input. They will input those. This commented section is was to check and make sure that the values are stored correctly. Then we use our class, so we instantiate an object Derek, and then it is equal to our 2-dimensional array, also passing the row and column. So we go up here, we have our function right here. It will parse through the 2-dimensional array. If the value is greater than max value, which is currently 0, then it will update the row, the column, and the max value, and it will work through the 2-dimensional array. Then we return to the main function. We will print out the largest value is and use the member function get max value, which returns that, and then the location is member function get row, which returns row, and the column, which is get column. That does it for this week's homework.